We are Team 1 and our interim presentation is on battery-powered pencil sharpener. And our members are Selena, Ruben, James, and Hope. First is product description. A battery-powered pencil sharpener is a device used to sharpen the point of a pencil automatically. A blade assembly is spun around the dull tip of the pencil, shaving away wood to sharpen the tip. The spinning blades are powered by a small motor. The blades are metal along with a few other internal components, and the outer casing is plastic. The blades were likely made with sheet metal forming, while the plastic components were likely made with injection molding. This is the exploded view for our pencil sharpener. We could see part 1 is the outer casing, which is the top red part of the product. It's connected to part 2, which is the washer and the spring, in which they are then connected to the blade of the sharpener. They are then assembled to the motor, which is the main part of the product, and inside the motor we have the chamber and 3 metal strips. On the motor we also have the battery panel along with the bottom panel. The bottom part of the sharpener also has a chamber casing, which is where the wood will be collected after a pencil is sharpened. For primary customers, we said it would be people in the education system, such as students and teachers, since they are likely to use sharpened pencils on a daily basis. Secondary customers might include artists and industry professionals, such as engineers and architects, when they need to draw sketches for their designs. It could also be factory workers who are producing pencil sharpeners. This is the fast diagram for the pencil sharpener. Its main function is sharpening pencils, and it contains several functions, such as contain shavings, prevent injury, remove wood, and it also have other sub-functions such as assure dependability, in which could have other functions such as guide pencil, stabilize pencil, and assure convenience, enhance product, and then please senses, in which could be subdivided into minimize noise and be aesthetically pleasing.
The first assembly sequence is best described as bottom up. It starts with the bottom panel, followed by the battery panel and metal strips, then the chamber, motor, blade, washer and spring, outer casing, and finally chamber casing. The second sequence can be considered top down. It is the reverse of the first sequence, and it starts with the outer casing, then moves to the washer and spring. The blade and motor have to become a sub-assembly with the chamber in this sequence. This assembly sequence analysis compares the sequences, scoring them in each category from 1, which is the worst, to 3. The first sequence from bottom up was the better of the two, particularly for handling and locating parts. With gravity helping the process, it became a bit easier. The function component mapping matrix is shown here. The blade, motor, and battery components all help remove the wood. The casings contain shavings and assure convenience. The washer and spring both guide the pencil to the blade and stabilize it during use. The chamber casing enhances the product, especially by allowing the shavings to be emptied after use. The outer casing in this design is the only part which helps prevent injury.
This is our bill of materials. It lists each part, of which there are 15 in total, including fasteners, as well as every process and every cost that is incurred by each part. Note that the costs are estimates and are done with certain assumptions. These assumptions I will talk about on slide 12. Note that for all the fasteners, the only cost is total cost. This is because for each of those, we simply looked up how much it would be to order them in bulk and then divided by batch size. The total cost ended up being just under $6, which may be an overestimate, as I will go into on the next slide. In order to reasonably estimate the costs for each part, we did have to make some assumptions, and they are listed here. Most of them are justified through information directly from lectures, so we feel fairly confident in each of them. However, they are in the end still assumptions, so they may have contributed to the total cost of $6 being a little bit high. We designated our primary audience as students and teachers, reasoning that the largest demand for pencil sharpeners was in the classroom. With this in mind, we designed 2 additional features to make this more appealing to our primary audience, one of which is a safety cover, which helps prevent injuries for children, and the second is a different outer casing, which makes the sharpener more appealing by having a fun face on the outside of it.
Taking our fast diagram into account, we can create a functional differentiation table, separating functions from the fast diagram into these two categories. Some functions that are the same for both customer groups as contain shavings, guiding, and sharpening the pencil, whereas preventing injury and appearing aesthetically pleasing was chosen to be different for each customer group. Furthermore, the component commonality table shows us which parts will be common and which parts will be unique. The safety cover and outer casing were chosen as the modules in order to allow for variety of the pencil sharpener while still being easy for manufacturability. Here we can see an assembly diagram based on the original assembly sequence from slide 6. Just before the chamber casing is new outer casing and safety cover. Using delayed differentiation, we can modify the assembly diagram to include the safety cover and outer casing at the end of the sequence. This is beneficial for creating the pencil sharpener for the two different groups. The outer casing step can be performed at the end for both groups. However, students and teachers will be receiving the modified outer casing with the smiley face and safety cover, whereas the artists and industry professionals will be receiving the plain outer casing. This concludes our presentation. Thank you.